Hello, and welcome to this Code Rage session on C++ Builder App Tethering. My name is Mannarino, and I'm one of the Embarcadero software consultants. For this session on App Tethering, I'll quickly explain what is App Tethering, and then we'll look at the two App Tethering components, the T Tethering Manager and the T Tethering App Profile. Then we'll look at some sample applications to show how to send data, send streams, and how to execute remote actions on app tethered apps. And we'll have a quick look at the refactoring of the app tethering communications that we did in 10 Seattle. And lastly, we'll have a look at some additional app tethering resources, and we'll have time at the end for any questions you might have. App tethering was first introduced in XE6 as a way to extend your VCL and FireMonkey desktop apps to other companion applications. And the companion applications can be Windows, Mac OS X, and/or FireMonkey multi-device apps. This slide shows just two of the many possible examples of what you can do with app tethering. So this first app is an existing VCL Windows app that manages and updates inventory of your warehouse database, a VCL or FireMonkey desktop application that is tethered to a companion application over Wi-Fi or classic Bluetooth. The VCL desktop app is a database application, so each time an item's stock is under the minimal stock value, a shopping list gets generated and is sent to all of the connected app tethering clients. So the companion app, like this mobile client, this is the client receiving the shopping list. So let's say, for example, by clicking a button, you'll be able to buy 100 units of an item, and then that change gets reflected on the VCL or the FireMonkey desktop app and all of the other connected clients. The second example is a FireMonkey app that scans photos, and then you can use a remote companion app to take the photo and then pass it to your central database to do employee badging. So with app tethering, you can properly and safely exchange streams and data messages between apps. And with app tethering, you can execute remote actions like pressing a button remotely or moving a trackbar remotely. In XE8 for app tethering, we added protocol enhancements and event handlers for hooks to add your own encryptions for stream and data being sent between connected apps. So to the tethering app profile, we added these four new events. We have on before send stream, and on after receive stream, on before send data, and on after receive data. And you can now use these new events as encryption intercepts on the two or more sides of the app tethering communication channels, that when you get a stream or data, you can do processing on the stream or data and encrypt the stream or data, and then you can decrypt the stream or data on the other end. So the conversations in app tethering between the two or more machines can now easily use custom encryptions. So you can now easily use app tethering to extend your existing VCL or FireMonkey desktop application user interfaces, the data and control to other desktop, mobile, and wearable devices using network Wi-Fi, Ethernet, or Bluetooth Classic. With app tethering, you can use the app tethering components to build connected apps to add to a distributed Internet of Things solution. So the app tethering technology lets us easily distribute an existing app user experience across devices and gadgets. So this is especially powerful for extending the utility of an existing desktop and mobile apps to integrate with the Internet of Things. So today we're surrounded by all of these devices, gadgets, and wearables. So there are all kinds of Internet of Things devices that we can now connect to using Red Studio. And with app tethering, you can now breathe new life into your existing Windows apps by extending Windows VCL and FireMonkey apps, connecting devices, sensors, data, and services. So all of that is great. For those of you that are new to App Tethering, let me quickly go over these two App Tethering components, the Tethering Manager and the Tethering App Profile. So the Runtime Library provides these two App Tethering components, giving your applications the ability to interact with other applications running either on the same machine or on a remote machine. And using App Tethering, your applications can easily discover other applications that are using App Tethering, running either on the same device as your application or on other connected devices. You can run actions remotely. An application can publish actions using App Tethering. Then other applications can remotely invoke any of these actions on the former application. And you can share data and streams between applications because App Tethering allows the sharing of standard data types and streams. These two App Tethering components follow the Bluetooth profile model. There's a main component and then a profile that implements the functionality. The Tethering Manager is the component that manages all basic operations such as auto discovery and pairing with other remote managers. The Tethering App Profile, it implements the application profile. So it's a set of functionality that includes executing remote actions, sharing resources, and sending streams and strings between other paired profiles. Now a manager needs to register a profile to start. So you need to drop both a Tethering Manager component and a Tethering App Profile component onto your VCL or FireMonkey form and then link both components, filling in the manager property in the profile component. So then to find other Tether managers in the network, you need to execute the function AutoConnect or Discover Managers. So when you use AutoConnect, this starts the automatic connection to remote managers on each registered adapter. And if you use Discover Managers, this starts the discovery of remote managers on each registered adapter. C++ Builder 10 Seattle includes some very nice app tethering examples. You have this database ShoppingList app that shows app tethering, sharing data resources between other paired profiles. There's a media player app that shows app tethering, executing remote actions like play, stop, and volume control using remote control between other paired profiles. There's a media player high definition app that's multi-device, so you can run this on Windows or Mac desktop, Android and or iOS devices for playing the media. And then you have a separate media player command app for remote control to the video player. And you can also deploy this as a multi-device application on Android, iOS, Windows, and or Mac OS X if you want to. There's a really nice desktop cast app that shows sending screenshots and actions to other paired apps. So any of the apps can take live screenshots and then live cast the image to the other connected apps. And lastly, you have this nice desktop beacon cast app that shows how to use tethering with the T-beacon component in a client application to scan for beacon devices. So this app shows how you can take some actions on a specific beacon device. So the server and the client applications connect to each other using app tethering, and then the client scans and finds beacon devices, and then remote actions are executed to take and get a screenshot from the server. So these are all really great app tethering samples to take a look at on how to use app tethering. So now let's go take a look at some of these app tethering examples.
Is an app tethering app called, it's a chat room app. So I'm going to fire it up. So let's say this is me here in New York City, and we have David running the same app in California. And let's say we have Jim, he's in Idaho, and we got Nick, who's in Virginia. We're all running the same app, and we're all logging in. So I log in as me, David logs in as he. And as you see, as we're logging in, each of the individual apps has its own unique ID, so it can be uniquely identified by all the other connected apps. And as we're logging in, we see where we're sharing data resources between each other. And here is going to be Jim. Jim logs in, and finally, Nick logs in. What's nice about app tethering, right? In this case, it's only one app, so there's no concept of a client and a server. So each one can be a client, each one can be a server, and they can all just communicate among themselves. So for me over here, I can send a message, hello from New York City, post it, and everybody gets that message. David from California, hello from CA, and then we got Jim, hello, and Nick in his state of Pennsylvania from PA. So by doing this was an example of being able to share data among other tethered apps. So you can see all the messages that got received and all the posts that got created. All right, so that was one example of using app tethering to share data between other connected apps.
Next, let's look at this C++ Builder 10 Seattle database shopping list app. So we have a VCL Windows desktop database application, and we created this FireMonkey multi-device client application that's going to receive a shopping list each time a product stock is under the minimal stock value, and then these client apps can place orders to buy product to increase the stock. Let me first run these apps, and then we'll look into the code to see how we added app tethering. So first, for the Windows VCL app, before I run it, I'm going to change its VCL style. So to do that, it's Project, Options, Application Appearance. And for this app, I'm going to select the new modern Windows 10 blue style and say OK. And now run the app. So now it should show up with this nice modern Windows 10 blue style like we see here. So that's great. And to our FireMonkey client application, I added this nice FireMonkey premium style called Emerald Crystal. And we did that by dropping a style book component onto the form, double clicking it, and selecting from the FireMonkey premium style pack this style called Emerald Crystal. So open, apply, and close. So now let me run the FireMonkey client app as a Windows 32-bit app. Say run. And it comes up. Great. These are the apps running. So we have our VCL Windows desktop application, and I started up 2 of our client applications. So this could be me here in New York, and this could be David I in California. On the Windows desktop app, each time a product stock is under the minimal stock value, a shopping list gets generated, and it's going to get sent to all of the connected app tethered clients. So me here in New York, let me click on the connect button to App Tether Connect to the Windows desktop app, and you see I get the shopping list. And then we can have David I in California also click on connect to App Tether to connect also to the Windows desktop app, and he also gets the same shopping list that I see. The shopping list shows each of the products and how many more of the items are needed, and we could buy 100 more of the units of the item by pressing the button. So for example, we see that this item needs 900 more. So if I click the buy button, the buy command gets sent to the database app, and the change gets reflected both on the VCL database app and also on our FireMonkey connected apps. So David I also can see that a product also needs an additional 200 units. So he'll go ahead and click the buy 100 button here. So we see the change gets reflected on the VCL database app and on all the connected client apps. So that really works great. So let's now go into C++ Builder 10 Seattle and look into the code and see how we added app tethering to these applications. This is the App Tethering database shopping list app in C++ Builder 10 Seattle that we just saw running. So this is the VCL desktop database app, and this is the FireMonkey companion app. For both the VCL Windows desktop app and the FireMonkey client companion app, we added the 2 app tethering components. We added our tethering manager and our tethering app profile component. So now a manager needs to register a profile to start. So that's why you need to drop both a Tethering Manager component and a Tethering App Profile component onto the form, and then you link both components, filling in the Manager property in the Profile component to be your Tethering Manager component. Tethering Manager component, we see we have a property called Allowed Adapters, and this allows me to switch from either using network Wi-Fi to Bluetooth to connect. For this application, we're going to connect using network Wi-Fi. Now for the client to connect to find other Tether applications in the network, the client needs to execute either the Auto Connect or Discover Managers. So when I click on my Connect button, we see in this case we are using Auto Connect. So I call the Tethering Managers Auto Connect method that allows me to connect or find other tethered managers. Now when this timeout finishes from our Tethering Manager, an event called onEndAutoConnect fires, and from here is where we're going to receive a list of discovered remote managers. And from this list of remote managers, you can choose the ones you want to pair with. Now for our Tethering Manager, we added a password. So when you want to make a manager private, you have to fill in a password, because if another manager wants to pair with you, it needs to know this password to be able to pair. So if the manager is protected by a password, as it is in this application, then you receive this event on request manager password with the remote manager identifier and a password variable to fill. So you need to provide this password to be able to pair. Now if the password is wrong, then you get this on auth error from remote event. But if the pairing is okay, then you would receive this on paired to remote event along with the on end auto connect event with all of the profiles found in that manager. So now that we have our Tethering Manager connected to our Tethering App Profile, we can now share data or streams or remote actions with other profiles. We use the Tethering App Profile to be able to add either shared actions and or shared resources. So for this example, we're using shared resources. So the Tethering App Profile component, it has a property called resources, and here is where we can add our resources. The resource type could either be data, and that's what we're using in this application, or it can be a stream. And it also has a public name that is used in order to be referenced outside. In this case, our name is Resource Shopping List. Next, let's look at the VCL database app. Its Tethering App Profile component. It has an event called onResourceReceived, and this event gets fired when we receive the data, and this is the code we're going to use to add 100 more of the stock item. There are two more items I want to show you on this app. The first one, if we look at our companion app, it's using a list view, and on its on button click event for the list view, and here's where we send the string by item to the connected tethered app, and then the connected database tethered app performs the on resource received event and adds 100 to the product stock value for the item. And on the VCL database form, on its on create, here's where we call the client dataset products load from file to get our products database, and on its on close event, here as we do client dataset products save to file. And lastly, create shopping list. This is what we use to create the shopping list, and create shopping list also checks to see if the product minimum stock value is greater than the product stock value, and if it is, we add that product to our shopping list. So these apps showed how you could use App Tethering to send data to connected apps using the tethering profiles send string method. Next, let's look at some other C++ Builder 10 Seattle app tethering applications. Here's the C++ Media Player app that shows how to send remote actions to tethered apps, like pressing the play button on a video player. And it also shows how to send strings to other tethered apps. We have a media player that plays the video. It uses a media player control and a media player component, and we added an action to play and pause the video, and we have a track bar for the volume, and we have a pause play button to play and pause the video, and we added an open dialog to pick the video to play. And to this media player, we added both our tethering manager component and we added our tethering app profile component onto the form. We created this FireMonkey companion app that can remote control the play and pause button and control the volume of the media player. And on this app, we also add our tethering manager component and our tethering app profile components onto the form. On the Find Media Players button, here we see we're calling the Discover Managers method of the App Tethering Manager, and we also see that we can pass in another parameter to search on a specific IP address or a subnet to discover managers, and we could also pass in another parameter for the amount of time that we want to spend searching for other managers to discover. For the tethering manager component, there is an event on end managers discovery, and here is where we get our list of discovered managers. And then the on end profiles discovery lets us pair or connect to our FireMonkey media player. And clicking the play pause button, this calls the tethering app profiles run remote action method, and we send the action play pause to our media player. And lastly, on the volumes track bars on change event, we call the tethering app profiles send string method, and it sends the string volume track to the media player. So this app shows how you can use app tethering to send both remote actions and strings to other tethered apps. So now let's run these apps and see how they work. So for my C++ Builder Media Player HD app, I'm going to build and deploy it to my Mac OS X machine. Let me go ahead and do that. Builds and deploys, that was great and really fast. And for my C++ Builder Media Player Remote Control Command app, for this one I want to build and deploy to my Android Nexus 7 tablet. So that's done. So here we see our C++ Builder FireMonkey Media Player app deployed to a Mac OS X desktop, and we have our C++ Media Player Command app deployed onto an Android Nexus 7 tablet. Right, let me load a video into our media player. Select the video, open. So we see the media is playing. I can pause it, I can play it, and I can control its volume. So that all works great. Let me pause it again. I now want to use our Media Player Command app as a remote control to be able to play and pause the video and also control its volume. So first I need to app tether to the application. So clicking on the Android device, it finds our FireMonkey Media Player. So now that it's connected, I can now send remote actions. So now when I click the play pause button on my Android, it plays the video. When I click it again, it pauses the video. And as I use the track bar to raise and lower the volume, you see the volume being raised and lowered on the media player. So all of that works great. So using this C++ Media Player app, we saw how you could send remote actions like pressing a play button on a video player by calling the Tethering app profiles run remote action method. And we also saw how you can send strings to other connected tethered apps by calling the Tethering app profiles send string method. And this allows you to send strings to other connected tethered apps. So all of this is great. So far we've seen how to use app tethering to send data and run remote actions. In this desktop cast app, we're going to see how to send streams like picture images between tethered apps. This VCL tethered desktop project, this is the server, so it can take full screenshots of the desktop window and then live cast the images to the other connected tethered apps. We have three actions. We have an action to take the full screenshot, an action to start the live cast, and an action to stop the live cast. And this server app is using low-level Windows API to get the desktop window, so that's cool. For this app, if we look at the Tethering app profile component and look at its property resources, we see in this case it has a resource type of stream. So for these apps, we're going to send streams between other tethered apps. The previous apps we saw were sending data between tethered apps. And this app is using a T-image component that'll display our desktop image. Let me run this server app, but before I do, I want to change its VCL style. So on the project options, application appearance, for this app, I'm going to pick the new Onyx Blue style that's also included in 10 Seattle. So I'll say OK, and now I can run the app. So the server comes up in this nice Onyx Blue VCL style. I'm going to take a full screenshot. So there's my screenshot. That works fine. And we see our desktop is displayed on our T-image component. Next, let's run the client companion app, and for this project we have both a FireMonkey version of the client app and we have a VCL version of the client app. Let's look at the FireMonkey version of the client app. So when we click on our connect button, we see that we call the Tethering Manager's Auto Connect method. For this app, we're using a timer, and this timer is going to check for remote profiles that we can connect to. So this is how our clients can app tether connect to our remote server app. The client companion app, if we look at its tethering app profile, it also has the same three actions. So it can also take a full screenshot, it can start a live cast, and it could also stop the live cast. Lastly, the Tethering app profile, it has a resources received event that calls load from stream the image it receives and then assigns the bitmap to the image component on the client app. So we already have the server app running. So let me start the FireMonkey client app and let's see how it works. Here's our server app and our client app running. When I click on the connect button, it calls the auto connect method of the Tether Manager, and then the T timer component, it checks for remote profiles to connect to, and as we see here, our client has app tethered connected to our remote server app, so that's great. On the server app, if I click the start live cast button, this will execute the action start cast, and this sends the stream, the picture image, to all of the app tethered connected client apps. So that works great. So this app showed how you can use app tethering to send streams between tethered apps, and it used the Tethering app profiles resource type of stream to do it. For this next topic, I'll let you know that new in 10 Seattle, we did refactoring of the app tethering communications. So meaning the base class for app tethering profiles, the T tethering profile, now implements logic to parse app tethering commands which was previously implemented in the base class for App Tethering protocols. And we also added logic to handle remote profiles and connections, which was previously implemented on its child class, the Tethering App Profile. This table shows the members that moved from the protocol classes to the profile classes. So in the previous release, XE8, the protocol classes were responsible for parsing the incoming data and building app tethering commands from the received data to pass those commands to a profile class. But now in Seattle, the protocol classes simply act as intermediaries to send and receive data streams. And the profiles are responsible for serializing and unserializing app tethering commands. So for a detailed list of the changes, you can see this link in the doc wiki on refactoring of the app tethering communications in Seattle. This chart shows app tethering platform support. So as you can see, with the exception of no classic Bluetooth on iOS, app tethering is supported on the four major platforms: Windows, Mac OS X, iOS, and Android, for both IP network Wi-Fi and classic Bluetooth connections. For app tethering resources, look at the samples included in CBuilder 10 Seattle. And during this session, we saw the first three samples on how to use app tethering to send data, send streams, and run remote actions. And for additional details on app tethering, see the doc wiki on using app tethering. And to give you a few more ideas of the types of apps you can build using app tethering, here's some examples from our Red Studio customers. There's a mobile barcode scanning and processing app with barcode data forwarded to VCL warehouse management applications. There's a medical mobile imaging app for doctors with a VCL management app using a mobile phone or tablet to take pictures of patients' conditions and send the images to dedicated app tethered VCL apps. There's a remoting device camera to desktop or different mobile device. There's a chat room app that I showed in this session that's a really nice example of building a chat room app using app tethering. And if you remember the Rad Studio Meteor game, there's an app tethered version that lets you use a FireMonkey remote control app to send the commands to move your ship right and left, and to thrust and to fire at the meteors. So there really is no end to the types of apps that you can create using app tethering. And remember, app tethering is a very easy way to extend your existing VCL and FireMonkey desktop apps to other companion apps. And those companion apps can be Windows apps, Mac OS X, and or FireMonkey multi-device apps. So that's all great. This ends this Code Rage session on using C++ Builder with app tethering. Now let's open up the session for any questions you might have. All right, questions on passwords in an app. What about security? So yes, if you recall from the beginning slide, so a couple of ways to do the passwords. We now added hooks or encryption hooks or password hooks into the app. So as before you send any data or streams between apps, then yes, you can ask for a password and check for that password. So you can also encrypt the information before it's sent on one side, and then decrypt it as it's being sent on the other side. So yes, you can add passwords to the app programmatically, pretty easy. And I do have several examples on how we do that. So when you get all your follow-up emails and the links for this, I'll post those examples for how to add passwords to app tethered apps and how to use those new encryption hooks that we have that allows you to decrypt the data first and then decrypt the data on the other side as it's being received. Let's see, what about Windows 7 and app tethering? I'm not exactly sure. exactly sure what you mean by that.
I think if I'm back on, I think he's just saying can he run his apps on Windows 7, Windows 8, Windows 10? Can they mix and match Windows 7, 8, 10? As long as they're built with the same version of C++ Builder Red Studio, it should be okay, right, Al?
Yes, absolutely correct. Yeah, so this app tethering technology just goes back to, I think it was XE6 when we first introduced app tethering. So for sure, any Windows 7 apps, Windows 8, 8.1, Windows 10 apps will all work fine with app tethering. Okay, another question. How many simultaneous users can tether to a desktop application? So, so if you recall, with app tethering, you can either use network Wi-Fi or classic Bluetooth. So it's pretty much limited on the bandwidth that you have, or unlimited based on the bandwidth that you have. I think in that one sample application had four folks in a chat room, and that works fine. So I don't think there's any real hard limit on how many simultaneous users can tether to a desktop application.
Okay, I'm just trying to type the answers here. Going back to that. You talked about it, there are event hooks. The first one was about the password. I know sometimes also in samples we just put the passwords in to, because we're trying to show the functionality of app tethering, not best practices for building your apps, of course. So, but there are many ways to take out of the executable in the form and so on and do other things. You might decide you want to buy some of those dongles that you plug into USB, and they have APIs that you could, for your app, go and see if the dongle's plugged in before you do certain things. Again, as you mentioned, there's those event hooks where you can capture the send and receive of streams and encrypt, decrypt the data or data stream. So it's basically bytes in, bytes out. So there's all of that stuff, and again, versions. I think the other thing, I'll ask the question, and I'll unmute you. There's another case you talked about, the network. Simultaneous users can tether to a desktop app. I know, for example, if you use Bluetooth, there was a conversation about not only network traffic on the network side, but Bluetooth. It's going to do UDP on port 2020 through 2040. There's some discovery time if you've got lots going on. So maybe you want to talk a little about maybe you have to set the discovery kind of timeout to a little bit longer if you're doing Bluetooth Classic versus network, for example.
So yeah, good point. So as part of that, one of the common questions I get is, what's the underlying technologies used by app tethering? So how does app tethering really work? So the app tethering discovery part works by using UDP to broadcast a discovery message, and I think by default we use ports 2020 to 2040 to find other tethered managers, and then it uses TCP/IP for the communications between the one or more apps on one or more of the machines. So it's important to note that those app tethered ports in your firewall, they need to be open, or you have to get them open. And as David mentioned, the more folks you have doing app tethering, you may need to increase that default timeout for the manager's discovery period. I think the default manager discovery period is something like 1500 milliseconds, and then the default timeout for the profiles discovery, I think that's about 5,000 milliseconds. So if your network is busy or you have a lot of simultaneous users on it, then as David mentioned, you may want to set the discovery timeout longer than that default 1500 milliseconds. So like, for example, if you're on a very busy network, instead of 1500 milliseconds, I normally bump it up to like 3000 milliseconds, and that gives me enough time for the managers to discover each other.
And there was one other question about sort of thinking about discovery as you move, you bring your smartphone into restaurants, gyms, being captured technology. Maybe beacons might be better. I guess your app could also discover if there's any apps to tether.
So see the question, I'm thinking on customers arriving to their service premises, restaurants, by this technology to offer them or to locate them in the database. It's correct to think this kind of app. Yeah, it's great work. One of those sample apps I showed that we include with it was the concept of using app tethering with beacons. So as you're walking into a restaurant, you have these beacons. So once the beacon gets acknowledged, then that could kick off app tethering. So yeah, this use case you have here would work quite fine with app tethering, and you could also add the T-beacon component to do both T-beacon and app tethering on the same app.
Yeah, especially if proximity might be important, then beacons are good. But just arrival, we've done these demos with walking into a doctor's office and so on. And so again, beacons just transmit. So, and then they go to your app, and then your app would have to do something with it, like the app would have to then call into the interface of the web service or whatever it might be that would have to go through a data snap or something to get to that database and do some things. Whereas in tethering, they may have a tether interface application running somewhere, and then your app would just directly go to the tether, or it could be see that it's in proximity and then go and discover the tether versus just always trying to look for tethered apps to discover. So you have to just think about your use cases and remember that that tethering, you're going to do discovery of tethered apps either through network or Bluetooth. And if you're using a beacons type system or GPS, for example, those devices are just broadcasting and you're using that data to do something, as opposed to you don't send data to a beacon, you don't send data to a temperature sensor unless for some reason it has some storage in it where you would want to do something, right, Al?
Correct, absolutely correct. Yeah, there's no, like I said, there's no real limit to the types of apps you can create with app tethering. It's kind of open, so you can easily send data, send streams, execute remote actions using app tethering. What's great about it is you can take your existing VCL and or FireMonkey apps and you can extend their lives, you can extend their utility by creating these companion apps. So take the features and the functions of your existing VCL and or FireMonkey apps that make sense and bring those over to companion apps. All right, they could be mobile apps or other desktop apps that can extend the life of that great existing VCL or FireMonkey desktop app that you already have.
Or again, it's a non-visual control. It could be a console app, it could be a server app, it could be any app that you can drop the tether manager and profile in. I think the other thing to think about is not just extending the life, but you may want to think about some re-architecting maybe. The good news is, though, if you have existing apps, you just drop these other components in, and it was architected to work the way your applications may already be defined to work. So if you use actions, and Al talked about that and showed it, you already have actions in your app. A tethered app that's the tether client can fire actions on your target tethered application. So it's not like you have to all of a sudden now, oh, how do I figure out how to integrate actions or something? It just works the way you work. I think the other thing is think about use cases and then contact us with some use cases if you're not sure about. One of the things that happened, I'm not at liberty to say who the customer was, but Al was visiting a customer and showing them app tethering a few releases ago, and they said, well, we've got some things we want to tether with, but they're on a completely different subnet. And, originally you had to be on the same subnet in order to tether, whether it was Wi-Fi or, so on. And Al came back to the product team and came back to R&D, and they figured out a way to create a method to pass an IP address to just connect directly rather than because, imagine somebody had asked when we first came out with this, can I discover all the tethered apps on the internet? So imagine the discovery time. Maybe you'd have like the Google of app tethering where you would index, all of the tethered apps. We weren't trying in the days of SOAP. You had this, UDDI, you had this directory thing and so on. We weren't trying to do that, but R&D figured out a way, and then that became a feature, right, Al?
Yeah, that was really a needed feature. So as David mentions, when we first came out with App Tethering, the default behavior of either Auto Connect or Discover Manager was that it performed discovery only on the local subnet of your local area network where the device was running the app. So that's great if everything was on the same local area network and the same subnet, but in the real world it's not like that. So based on this feedback from the customers, in the next release, XE7, we added those two optional parameters, one being a target to override that default behavior, to let you specify a target IP address or a subnet to search for a remote manager. So now as a result, you can now use App Tethering to connect to devices in different subnets of the same LAN or devices with completely different IP addresses. So now with App Tethering, you have connections outside of your subnet, and that's really great.
Okay, Al, it looks like, we started early because I did like yesterday, here in the C++ room, people control it, not me, and we finished the previous session early with Ray and talked a little Chicago Cubs baseball. He didn't say whether he wanted the Dodgers or the Mets to be playing the Cubbies in the next round, but you're in the New York area. Maybe you have thoughts now that the Yankees are out. But that's baseball, and I don't know. Well, it is October. So that's why we started a little early. I probably threw you off because you came in and all of a sudden things were going on. But thanks for being flexible, and it allows us to spend a little time here and also finish a little early. So, Al, you get the last word. I'm going to open up your mic and shut myself off.
All right, so yeah, I did. When I did get on, I thought I was in a different time zone, and I wasn't sure if I was on the right session or not. So thanks for that clarification. And I'm going to end this with big round of applause to David I and Jim McKeith for doing these Code Rage sessions, because I love them. I learned so much from these sessions. So once again, big round of applause for David I and Jim McKeith and Embarcadero for doing these great Code Rage session. So hopefully they'll continue to do that. And in App Tethering, a great technology. So if you haven't seen it yet or you haven't used it yet, get inside of Rad Studio 10 Seattle or CBuilder 10 Seattle and take a look at those examples, and hopefully it'll open up some great ideas on what you can do with App Tethering using Rad Studio.